All right, let's go over a couple different types of biasing circuits. So, right now we have the one that a lot of builders use. BBI has shown it one time in detail, and the guy's got a lot of information. Just sometimes trying to find it with his library of information. Um, it can be hard to find, right? And especially if it's only a 5-minute snippet in a 2-hour video. Keep up the good work, but sometimes we just need a video about just biasing, how it's done, what do you got to do. And I know that a lot of builders, these are the secrets in the vaults, but there is so much work out there, and I'm not a builder, just a guy who wants to work on his own stuff and not have to wait or depend on other people. And I think there's enough of us out there that are willing to tackle little things like this. And there's still more than enough people who don't want to touch this. They just want to talk, send their stuff in to one of the, 20 amp builder repair shops that are still out there. BBI, Gatekeeper, 3Made, Rainmaker, Tech 9. I'm getting off on a tangent. So this is the circuit BBI has said. And what we got is we have a 10 ohm. And I didn't have a 15 watt, but I believe he uses a 15 watt sandstone. This is a 10 ohm, 10 watt high voltage ohmite. It's good enough because we're not going to let it run forever, but it's good enough for the demonstration. So what we're doing is we got our 10 ohm going to a 5820 diode. Now that diode, in conjunction with this 10 ohm, this is a 0.1 volt drop diode. So it's a very low voltage drop compared to most diodes, which are about a half a volt. But the 5820s are only a 0.1 volt drop, 0.15 or something. And we've got a little, very small, 22 to 30 microfarad cap, electrolytic, and then we have a 104 disc capacitor down here. And these are for RF filtering. This is to make sure RF doesn't go backwards from the transformer into your DC circuit. More or less, these are just filters. This 10 ohm, these pack of 10 ohms here is for the Gatekeeper style, which we'll get to that next. But they're disconnected, they're not doing anything. These are my sideband delay, capacitors, relay. Here's my bias relay. Okay, so basically both of those get the signal from the keying relay circuit. You got to add a couple of diodes like I have right here to make sure that it doesn't mess with the keying relay, get it stuck on or anything like that. But essentially, let's just go over mainly the different component values. 10 ohm, 5820 diode. So let's come down here. We are on 15.3 volts DC in the power supply. So we've set it for 50 ohm dead key. 50 watt dead key. And that gets us a 230-ish milliamp bias and a 20 amp draw. Now under modulation, we get about 450 watts. Let's see what it does with our bias drift along with our current draw. These are 2879Cs. Audio. So not a lot of drift, Not a lot of drift at all. So now, as far as voltage goes, we could rework this real quick and show you what the voltage shows us on that pad to get us this roughly 250 milliamps. Audio 208. Between 250 and 280. 230 and 280. Audio. Okay. So let me pause it. I'll connect that to this pad, and then we'll just check what the voltage is. Okay. So we've moved the leaders around. Now we've got ground from the case, power to our little pad, which is the amount of voltage now that we would see. Now, mind you, bias is set with current, not with voltage. But you can use voltage to get you in the range. But if you have the ability to check with current, milliamps, check with milliamps. So now, for voltage, we're seeing 326 millivolts. Now, that got us 230 milliamps. And we're seeing 320 millivolts. So, it's not a one-to-one. And as we go through here, maybe we can see, how many amps equates to how many volts, and you can determine the percentage drift. But your millivolts, your milliamps are not identical. So we were seeing 250 millivolts at 230 milliamps on a 50 watt dead key. And now we're seeing 330 millivolts. So there's our 20 amp dead current draw. Now, there was a little bit of drift in the current during modulation. What does the voltage do? Audio. So really no voltage drift in this style circuit. So you see 330 millivolts equates you to about 250, we'll call it right in the middle, 250 milliamps of bias. I believe that puts you right at like the bare minimum of class B. So you're like, you have some bias. Your signal will be cleaner. But as far as harmonics goes, but as far as audio, it's not as good as it could be, especially for the sideband guys who really like that crazy clean audio, right? The higher in class you can go, B, A, stay away from A. But you want a solid AB to get the cleanest audio. Okay, so now we're going to switch it and go to the gatekeeper circuit that he has also shown online. So I'm not like spilling any trade secrets here. We switch that around and we'll go to that.